Finding a veteran team that really understands the deep challenges of translating new technology into legacy industries is critical. And the Aqualith team understands this better than anybody else. They know they have the best technology, but that's not enough to win. They have a technology that's easily manufacturable, low cost, and readily available, even domestically here in the US.
Of the tens of thousands of design decisions that go into the creation of a new electric vehicle, the one decision that is perhaps most consequential for the profitability of that vehicle is the choice of anode material.
Aqualith sells next-generation battery materials so EV makers can leapfrog low-cost batteries that only trade policy and tariffs are preventing from flooding the US and European markets. Our first product is a next-gen anode material that is inherently cheaper than the incumbent, graphite. In fact, in the US, we already produce enough of this material to make 20 million new EV batteries every year. And it's cheap.
Silicon. Pound for pound, it packs almost 10 times more punch than graphite.
The problem is, our OEM friends fear silicon anodes because they think they don't scale. This $200,000 car's silicon anodes are actually 90% graphite and a mere 10% silicon. What's more, these minute quantities of nanosilicon eke out just a 7% performance improvement.
Nanosilicon only works in a car that costs as much as a condo in Orlando.
The problem isn't the material, it's the manufacturing. See, nanosilicon companies have spent billions in funding to prove they can make nanosilicon, borrowing from advanced semiconductor manufacturing and even using toxic gases as their starting materials.
That's the irony of nanosilicon. It comes at giga cost.
Our 100% silicon anode material is made from microsilicon. It comes from sand and gravel and is made using the same equipment that grinds cement. Our anodes are almost 4 times cheaper than graphite ones and 20 times cheaper than nanosilicon ones. We've got decades of leadership experience in the advanced materials and EV charging industries. And we've sat down with battery experts from car makers and tier ones in Europe, Japan, Korea, and the US. Most important for OEMs is that our microsilicon anodes are indestructible. We've already proven this with our 800 cycle life coin cells. And because of our proprietary, self-limiting, solid electrolyte interface, our silicon anodes have the calendar life necessary for mass market EVs.
All this translates to a promise of at least 25% increased profits for EV makers who are feeling the pressure of stalling early adoption and who need to unlock the next wave of price-conscious EV buyers.
We are optimizing our pouch cells to meet our customers' base specs. We start qualification in 2024. Our already manufacturable microsilicon anodes can move from A-sample to production vehicle faster than any new battery material out there.
We're better.
Cheaper.
And faster.